Hello and welcome to Programming Rush. Today in this video we are going to learn the insertion sort algorithm. So let's proceed. So first of all we are going to learn the algorithm itself. So what is insertion sort algorithm? Insertion sort algorithm is a simple sorting algorithm that builds the final sorted array one item at a time. It is very much less efficient because it has a time complexity of big O of n square, but the better part is it has a space complexity of big O of 1. The algorithms like quicksort, heap sort or merge sort work much better, but it has a very interesting concept, so it should we learn it. So what is the implementation? Implementation works in 3 steps. The first step involves the comparison of the key element with its adjacent element. If the comparison reveals or shows that the key element can be inserted at a particular position, then the space is created for it, shifting the other elements to the right, and the insert element is inserted, and it is continued until all the elements are at the perfect position. Now we are considering here an example where we have an array of 4, 2, 7, 9, 12, and 5. So first iteration says the key element is 4 and 4 is greater than 2, so swap it. We can also think it as comparing 2 with the 4 and 4 is greater than 2, so swap it. Normally the array starts always from this point. In our code we will always start from this position, the index 1, but for the explanation purpose we are moving from 0. Now in the second iteration we checked for the position 1, so let us move to the index 2, and here the 7, we have got 7. The 7 is greater than 2 and greater than 4, so we have got our array as 2, 4, 7 until now. In the third iteration we check for the index 3, where we have the element 9, which is again greater than all the 3 elements, and at the index 4 we have got 12, which is greater than all of these 4 elements previously. Now at index 5 we have got 10. Now 10 is greater than 12, so we need to swap it, and we have swapped it, and we have got the array like 2, 4, 7, 9, 10, 12, 5. Now 10 is greater than all of the previous 4 elements, so no need to swap it. In the iteration 6 we have got the 6th element whose value is 5, and 5 is greater than 12, so swap it. Then again the 5 is greater than 10, swapped it, and then 5 is greater than 9, swapped it, and the swapping goes on until the element which is smaller than 5, which is the 4, but 7 is greater than 5, so we have swapped it, and finally we got our array as 2, 4, 5, 7, 9, 10, 12, 5. Sorry, 2, 4, 5, 7, 9, 10, 12, and we have reached the previously to 5, the last index 6, so no need to move again, so we don't move again, and we got this sorted array as this. Now the pseudocode for the insertion sort works as like this. We have a for loop. Inside it we have two integers. First key, that is the ith element, and then the j, which acts at the pointer, and the pointer moves until 0, and we swap the elements until they are greater than j plus 1th element, means jth element, and finally we assign the j plus 1 element to the key. Now the implementation, we will implement the code in C++, but the pseudocode would be applicable for all the programming language like Java, Python, etc. So we have moved to the code part. Okay, so in the main function we have the array as the same array we took example with 2 more elements. Now we call the insertion sort function, and the insertion sort function works very much similar to the pseudocode. We have the array and the length of the array, and we run a for loop from one position, that is index 1, not index 0. The array is index 0, but we do from the index 1, and then we take the key element, the jth element, and run a while loop, and swap the elements until the previous element is greater than the key element. And finally we initialize means we assign the j plus 1th element as key, and if the key element is all greater than the previous element, it does not changes. And finally we print the array here, as we can see. And now let us see the output for this code. So g++ insertion, let us move, yeah. So the output is 2 3 4 5 7 9 10 12 33. So we get the output as this, and we have got this sorted array. So we have implemented the code in the C++, and again I am saying it is applicable for all the programming languages. So thank you all for watching this video. Share it among your friends and subscribe Programming Rush. The code link is given in the description, and see you in the next video. Thank you.